Hi, this is John, and today we're going to look at the middle school science unit, Natural Hazards, and this is in the Summit platform. So, as I examined the course using the rubric, I was pretty certain that there were going to be some key elements of a competency-ready course that would be missing. And of course, the first one was that there isn't a competency. So I took a look at the standards to see what exactly was included in this unit and to see if there was anything that I could make a connection to the existing competencies. What I found is that there are 18 standards listed, including 2 related specifically to Earth's systems. However, the rest of the standards are divided among the cross-cutting concepts, engineering design, and the science and engineering practices. Now, 18 standards is a lot. And so as I look closely at this later on, as I continue this process, I'm going to make certain that I make a note to myself to look at which standards are explicitly taught and assessed, and then as well to see if there's any redundancy in the standards. I'm thinking the explicit instruction and assessment of the standards is going to be something that is potentially a problem. And it's going to allow us as well, though, to really focus in and cut down the 18 standards. The performance task for the unit is an engineering report, and that makes sense for the standards that are being assessed. It's designed as a simplified lab report and references lots of higher-order thinking skills, such as making inferences, hypothesizing, and interpreting data. The project breaks down the engineering design process into 4 discrete steps: defining the problem, developing a solution, interpreting test results, and critiquing a peer's design. It's simplified, and so I'm not entirely certain that those are the right steps. But it does parallel the learning cycle, so I can definitely leverage that as I make some changes. I can see that there will be lots of opportunities for students to collaborate and to give and get feedback, and that's a great asset. I wonder, though, if there's lots of reflection included as students move through the process. I'm thinking that, again, there probably isn't, so I'll need to develop some reflection questions for the students. As I take a cursory glance through each of the steps, I see that they aren't particularly well scaffolded. I'll definitely need to bring in some supplementary materials. I'll look at a place like Science Buddies, maybe the NASA website, and see what else I can bring in with respect to the engineering design process. I also see that the resources don't provide many options for students and that they might not be terribly engaging. So that's another opportunity to pull some other assets into the lessons as well. The performance task does raise an important red flag for me, though. I don't see how the earth science, both of the earth science standards are addressed here. And I'm going to have to circle back to take a look at that later as well. And that may be one of the standards that we just cut from this project, but we'll see. I look at the performance task problem frame, and it's actually not too bad. It establishes the reason and the task that students are going to do, and it's pretty authentic. My main concern is that it may not be something that students can relate to, so I'm going to have to think about that and probably make some tweaks. The essential questions as well are going to need a little bit of tuning. They seem right now kind of broad and, again, not really connected to students' experience, so we're going to have to do a little bit of tweaking there. Overall, I see that there are lots of opportunities for wordsmithing and making some adjustments and adding additional resources. That said, there's a pretty strong foundation here. It just needs a little bit more fit and finish.